Hey guys, this is the 3.5 part 1 video. We're going to be starting to look at transformations of those parent functions that we talked about yesterday. So first let's start with vertical translations. So that is when the graph shifts up or down. Shifting up or down, that's vertical, right? So given a function f of x, a new function, g of x, equals f of x plus k. So you are adding a number to the outside of the function. Okay, so this number is going to usually come after the function, but it will never be inside of the operation that the function is performing. So it's going to be some number added after your function. Where k is a constant, it's going to be a vertical shift of the function f of x. So anytime that number is being added outside of the function, it's going to cause that vertical or up or down shift. If k is positive, the graph is going to shift up. Okay, so that's if you have a plus k here at the end. If k is negative, the graph is going to shift down. And then if you look at the ordered pairs for that graph, for every point x, y on the graph of f, there will be a corresponding point x, comma, y plus k on the graph of G. So what that k ends up doing is shifting it up or down, right? But it's actually just going to affect the y values. The x's don't change, but those y values will get plus k added to them. So say k is a negative number, then it would be y minus that number. Then that's how the graph will change. So you could look at the transformation as it shifting up a certain value or down a certain value, or you can actually take individual points and then add or subtract that k value to find the new point, adding or subtracting that from the y value specifically. So let's look at Desmos really quickly because they give you can get a nice illustration of what exactly k does here. So I have this slider, and right now I have the parent function for the absolute value graph here on our graph. So let's see what happens as I shift this k, this slider, to the left and right. So if I make k 5, let's say, see how it just shifted that graph up 5. And now that point, it started at 0, 0, but now it is at 5, 0. So all that you did was add 5 to the y value. So each of those y values are just the number k is being added to them. Now let's see what happens if I make k negative. If I make k negative 2, then notice that point went from 0, 0 to 0, negative 2. So you just took that y value and subtracted 2 from it. Same with every other point on this graph. You just subtracted 2 from the y value, and nothing else changed. The slopes of these lines are still 1. It's still that V shape. Nothing else changed. All right, it just shifted up or down based on that k value. So let's look at some examples. On all of these examples, I am going to graph the parent function first. So right now we're looking at the absolute value function. So let's graph the parent function. Y-intercepts at 0, 0, slope of 1, and negative 1 on the left-hand side. So I'll sketch my line through those points. All right, so this is the parent function. graph. All right. Now we see we've got a -4 after the function. It is outside of the absolute value, so I know that's a k because it's outside of the absolute value. So k equals -4, which means my graph is going to shift down 4. And then you could also think about how that affects each point on the graph. And that is going to be each xy is going to go to x comma y minus 4. The x doesn't change, but the y decreases by 4. So let's do that on the graph. So I've got this point 0, 0. X value doesn't change. Y value gets subtracted by 4. Subtracting by 4. Subtracting by 4. You could also just find that one point, that vertex there, that turning point 0, 0, and then use your, because you know the slope isn't going to change, you could just sketch each of those lines with the slopes of 1 and -1, or shift each point down 4. All right, so that is the transformed graph. That's the graph of g of x. Now let's look at a table. A function f of x is given in the table below. Create a table for the function g of x equals f of x plus 6. So our new function, g of x, is going to be that original function plus 6. Remember that f of x is the same thing as y. So what they're saying is take the y value, add 6. That's one way you could think of it. So we know this is k equals 6. So we literally need to do g of x equals that f of x plus 6, or y plus 6. So my x's aren't going to change. My y's get 6 added to them. And so I could plot those points on a graph. That would be the transformed function of f of x shifted up 6. Now let's talk about horizontal translations. So horizontal translation, if you're given a function f of x, a new function g of x equals f of x minus h. So up here with our vertical translations, the k was added outside of those parentheses after the function, but right here h is actually on the inside of the parentheses, directly being subtracted from the x. So h is a constant, aka h is a number, and it's going to be a horizontal shift of the function f of x. If h is negative, the graph is going to shift left. Now this can get a little confusing because when I say h is negative, I mean this number here is negative, but what does that mean about the middle sign? So let's say h equals a negative number. Then when I plug that in, that'll be x minus a negative number, which you can simplify to say x plus a number. So if the sign, if your h is negative, you actually end up with a plus sign here in between the x and the number, and that is going to make your graph shift left. So whichever way you want to think about it, h is going to have the opposite sign of what it appears here in parentheses. So h equals a negative number, gives you that plus sign, and it's going to shift you to the left. Now, if h is positive, the graph is going to shift to the right. And so that is, if h equals a positive number, then you're going to have f of x minus that number. The sign does not change. So if you have the minus sign in the middle, then you know it's shifting to the right. It's kind of, to me, I always think of it as it's going to go the opposite way of what I would expect, right? Because when I see the plus sign in the middle, I would think it should move to the right because that's where the x values are larger. But because the original starts out with the minus sign, it actually goes the other direction. So it's actually going to go left when you have a plus sign and right when you have a minus sign. For every point x, y on the graph of f, there will be a corresponding point x plus h, k, oops, sorry, not k, y on the graph of G. So just like how you can add the k to each y value to get the new point, you can add h to each x value to get the new point for horizontal translations. Let's look at Desmos to see how this affects the graph. So I'm going to put this back at 0, the k. Now h. So remember, when h is positive, it should be moving to the right. When h is negative, it's going to move to the left. But that does change that middle sign in there to the opposite of what h is. Anyways, so if I move h to the right, I'm going to get some positive values. It should shift my graph to the right. So notice how each x value is just increasing by h. So you can take that h value of 2, add it to the original x value, and you get your new x value. So I had a point at 0, 0, add 2 to the x value, now I'm at 2, 0. I had a point at negative 2, 2, add 2 to the x value, that gives me 0, 2. Now if I make h negative, say negative 4, okay. Now I had 0, 0, now I have negative 4, 0, so it's only affecting the x value. It is subtracting 4 from the x value. And same thing with all of the other points. Nothing changed except the fact that the x values decreased by 4. Now keep in mind that if I plugged this negative 4 in for h here, that would be x minus negative 4. So the function would actually appear as x plus 4. Absolute value of x plus 4. And of course you can have a combination of these translations. You could be shifted to the left 4 and up 3. You can have multiple translations that can be shifted vertically and horizontally at the same time. But remember, h only affects your x values, k only affects your y values. So you could get the new points here by subtracting 4 from the x and adding 3 to the y. Let's look at some examples. So again, we're looking at absolute values. So let me graph the parent function. Starts at 0, 0, has a slope of 1 on the right side and a slope of negative 1 on the left side. All right, that's the parent. So remember, the parent function is just the function before any transformations have occurred. So now this one, I've got x minus 4. Well, the original notation of this is x minus h. So what is h? H is just the 4. H equals 4. And I know if h is positive, then I'm moving to the right. I can actually say x comma x, not x comma x, x comma y goes to x plus 4 comma y. So each of my x values I'm going to take and just add 4. We also know that this should shift our graph to the right 4. All right, so adding 4 here, there's my new point. And then my slope should be positive 1 still on the right and negative 1 still on the left. And there's the graph of g of x. Okay, looking at a table, a function f of x is given in the table below. Create a table for the function g of x equals f of x plus 2. So this is your h value. Remember, it was x minus h, but now it became a plus. How did it become a plus? Because h equals negative 2. So x minus negative 2 would give you the x plus 2 in the middle. So if h is negative, then to get my new x values, I just need to do x minus 2. That original x over here minus 2 will give me my new x values. Also, note that this is going to shift your graph to the left 2. Okay, so subtracting 2 from each of the original x values. And keeping your y values exactly the same. So those would be the new points on the graph of g of x, with the translation left 2.